Okay, so let's take a look at these here problems, see if you can remember our percents from last class. So for the first one, we always start, if we have it, we always start with the percent, and in this case it's 70%. So that is going to be 70 over 100. On the other side, what's going to go over there?
Blank on top and 90 on top.
Okay, so the blank on top, because the blank is the 70, and out of 90. So we cross multiply and divide, we get 63. 70 times 90 is 6,300, divided by 100 is 63. The second one, we have 30%, so we start 30 out of 100 equals, we have the 42 in the blank, which one goes where?
42 on top.
42 on top, blank on bottom. So I have 100 times 42 is 4,200, divided by 30 is 140. 42 is 30% of 140. And then finally, we start with the percent, but we don't have one here, so it's blank over 100. And on the other side, what goes where?
48 on top.
48 over 80. 48 is the blank percent, so 48 goes with the missing percent. Out of 80. And again, we cross, multiply, and divide. 100 times 48 is 4,800. Divided by 80 is 60. So 48 is 60% of 80. How many of those look familiar to you?
A lot.
Everybody got all three of them right?
Yes.
Good deal. Now, percents are one of the more powerful tools in mathematics. They kind of fit into a larger group, which is the ratio and proportion, which I think is probably the single most powerful tool in math. And we get into science and engineering, and there's all sorts of spots where ratios can be used to solve some pretty complex examples. And percents are a form of ratios. Percents are probably the most common form of a ratio. So what we're going to look at today is we're going to look at some applications of percents. Some, I think, very important applications of percents. And then we're going to do a little bit of review for the last part of the hour, because next Tuesday is today is the end of Unit 3, so next Tuesday is Unit 3 test. So if you've been following along on my math lab, you saw that one coming up. Okay, so one of the applications we have is commissions. If you're in a sales position, and again, there's other places other than sales where you deal with commissions, but it's most common in a sales position. You might get paid a commission off of your sales. One possible way to do it is a straight commission. Now, a straight commission is where your total pay is a percentage of your sales. If you make no sales, you get no pay. Some states have outlawed this now, just so you know, that you must have a minimum wage plus a commission on top of it. And we'll look at that in just a little bit. So let's say you have a straight commission of 12% of gross sales. That word gross is important. That means that you don't have to pay back if something you sell is returned. There are places where you might have weeks where some people return more stuff than what you sold, and you actually have a negative commission. So anyway, 12% of gross sales. And for a week where you have sales of $6,200, what is your pay for that week going to be? Well, 12% is 12 out of 100. Finding 12% out of the 6,200. 12 represents the commission, so our commission is going to go on top over here. That's what we're looking for. So we'll cross, multiply, and divide. 12 times 6,200 divided by 100 is, what, 7, what is it? 744? Thank you. $744. That is your pay for the week. So let's say you have straight commission of 9%. And you have sales for the week, $7,500. I'll give you a second to get a head start on me. Find what your pay for the week would be. $675? Perfect. So 9% is 9 out of 100. How much is that out of 7,500? You cross, multiply, and divide. You get $675. Now, we had mentioned something called rates last class, the rate method of percents, where instead of cross multiplying and dividing with the proportions, you just multiplied by a decimal. Commissions is one of the applications where that rate method is commonly used because you're usually only calculating in one direction. You may have, well, let's use this example, $7,500 worth of sales times, what's the rate? 0.09 is the decimal equivalent of 9%. So 7,500 times 0.09 is just going to be 675. So if you're going to make that calculation week after week, this is simpler and easier to do and easier to program into a computer, if you're going to use it that way, than this. So that's where the rates come in handy if it's a calculation that's going to happen over and over again, and it's just a simple finding the portion out of that whole amount. Now we can deal with commissions on a side of, let's say that you are going to get hired and you're going to get paid 8% straight commission. And let's say that you have figured it out and you need a minimum of $840 per week to pay your bills. If you don't make it at least $840 a week, you're not going to make it. So the question becomes, what's your minimum sales? Well, 8% is 8 over 100. Here I would not want to use the rate method. I mean, you could use the rate method, but it's simpler for me to go back to the proportion. Where's the 840 go? Does that represent the total amount of sales, or does that represent the commission? The commission, what we're going to get paid. Does the 100 represent the commission, or does the 8? The 8 represents the commission. So the 840 has to go on top, because the $840 and the 8% both represent the commission. So I'm going to stop there. Anybody have any questions why the 840 had to go on top? Because it is the piece, it is the percent, and we're looking now for the whole amount. So now 100 times 840 divided by 80, or divided by 8, sorry, is going to give us how much? $10,500 in sales. So we needed a minimum of $10,500 each week in sales. Now we talked about some states outlawing straight commission, where they have to give, they're required that you be given a certain minimum wage. It may not be standard minimum wage. Many states have different minimum wages depending on the type of job you work. What is for wait staff, what is it, like $2.35 or something like that in Wisconsin? I know, is it 5 something now? Okay, I know some states it's still, I mean, there are a couple of states that have, I know Nevada has no minimum wage for wait staff. Well, but if tips are good enough. Anyway, so let's say that you're going to have, let's go $6 per hour plus 3% commission. Why is the percentage so low? Well, because you're getting a minimum hour of the wage, you're not going to give you as high of a commission on your sales, are they? So let's say you have a week where you work 36 hours and have sales $8,100. Let's find your pay. Well, first thing we're going to have to do is the 36 hours times $6, which is going to give us $216. Not a terribly promising start, is it? What are we going to do with the sales? Times 0.03, which is going to give us what? $243 in commission. We add those up, we get $459 for the week. Any questions? Another way of doing it is to do a salary. Rather than giving an hourly wage plus commission, you might be given $200 per week plus 5%. You're getting a salary plus. So again, let's say we have a week where sales are $7,800. Let's figure out the pay. I'm going to have you guys try this one. So this one's actually a little bit easier because we don't have to figure out the hourly. That's going to be $200 period. Doesn't matter how many hours we put in. What do we do with the 7,800? 5% or 0.05, which is going to give us $390 plus the $200 per week. So $590 is the pay for the week. Not so bad? Okay. Sometimes, however, they adjust that a little bit. They might say you're going to get $300 per week plus 6% on sales over $3,000. What does this mean? Well, that means your first $3,000 in sales, you do not get a commission. They're saying this $300 a week, they're expecting you to get $3,000 in sales on top of that. So let's say that you have a week where your sales $9,300. Let's figure out your pay. Well, the first thing we have to do here is we're not going to figure out commission on $9,300. It's going to be commission on, subtract the $3,000 base, $6,300. That amount is going to be multiplied by the 6%, 0.06, which is going to give us $278. Plus the $300 per week, $678 to pay for the week. Make sense? Okay. You could run into a graduated commission scale. In a graduated commission scale, you might have something like this. Your commission on $0 to $500 or $5,000 worth of sales is 8%. 5,000 plus just means the penny after. Sometimes do 5,001 cent or something like that. To 10,000, you're going to get 9%. And $10,000 plus, they're going to give you 12% commission. So let's say we have a week where our sales are $7,800. Well, that $7,800 is going to get split up. How much of it is going to get put at the 8% commission? 5,000 times 0.08 is going to give us $400. How much is left? Yeah, 7,800 minus 5,000 leaves us 2,800. Is that going to go over our next one? No, it's not. So that full 2,800 is going to be at 9%, which is going to be what, 252? And there's nothing left to go into the 12%, so this is going to add up to $652 is the pay for the week. What if we have a great week where the weekly sales are $13,200? So now that $13,200 is going to get split up. The first $5,000 is going at 8% again, 0.08. That's $400. I'm going to do this. I'm going to take away $5,000 because now there's only 8,200 left. Out of that 8,200, the next 5,000, from 5,000 to 10,000, is at what amount? 9%, right? So 5,000 times 9% is $450 commission on that next 5,000. Now, of course, we do have to subtract another 5,000 from that because we've already paid the commission. What's left? 3,200, and that's going to get paid at what rate? 12%. $384. So that's going to be what, $1,234 is the check. I'd take that. Any questions? Now, this next concept isn't necessarily a math concept, but it's something I want to show you. We mentioned gross sales before. Well, let's say you're getting a 13% straight commission. And you have a week where you have sales of $8,500. But you also have returns of $1,300. A lot of stores do this because if you're doing straight commission, some people will start selling the higher priced items just so they can get the bigger commission, and then people don't like them, they return them. The incentive here is to sell people stuff that they will like so that they don't return it. Or there are some people, some places have had problems with friends will come in and buy stuff, then return it later, but you get the commission off of it. So you got to count the returns. So for this one, before we calculate the commission, we're just going to do sales minus returns to get a net sales instead of gross sales of $7,200. Then what? Times 13%, which is going to give us 936. There we go. So the returns cost us $169 worth of commission, if you were to figure it out. This next one, again, is not necessarily a math topic, but if I'm talking about commission, I have to show it to you. Because this word has got a lot of people in trouble through the years. Let's say you are offered a job, a sales job, where you are offered 8% straight commission. With an $800 guaranteed weekly draw. A lot of people look at that $800 and say they're guaranteeing me $40,000 a year. I can live with that. Well, let's take a look at what this really means. Let's do week 1. We have sales of, let's just do $5,000 in sales. The commission earned is 5,000 times 0.08 or $400. What are we going to get paid? 800. But we didn't earn 400. So the rest of that, 800 minus 400, is what they call a draw. Week 2, let's say sales have increased. You sell $7,000. Your commission, 8% of that is $560. What are you going to get paid? $800. But you only earned $560. So 800 minus 560 is $240. 400 plus 240 is now $640 that you have taken on draw. Week 3. Things are picking up a little bit. 9,000 in sales. 8% commission is $720. How much are you going to get paid? $800. Now you only earned $720, so the difference there is $80. To a total of $720 of draw so far. Week 4, you hit your stride. $12,000 in sales. Commission times 0.8 gives us $960. How much are you going to get paid? But you made $960.
You're in the hole.
Yeah.
You gotta pay it.
That other $160 comes out of your draw. Yep. And it has happened where the insurance industry was the biggest culprit of this. They give you that guaranteed weekly draw. And people get in there, and after a couple months, they'd realize they're no good at selling insurance. Or 2 or 3 months into it, and they realize they want to quit, but they have $4,000 or $5,000 in draw against the company. And if they want to quit, guess what happens? They have to pay it back immediately. So there was a risk there. If you knew you were good at sales, it was a good deal. If you had a slow time, or if you wanted to take vacation, you could take a draw and just pay it back after that. But there was a hazard to it. Some companies it was, at the end of the year, you paid it. You had to level up at the end of the fiscal year.
Yep.
Other companies, you could let it run up to a certain dollar amount, but still, it's a risk. Okay, we're going to change gears a little bit. We're going to look at percent increase and decrease problems. One application. Well, let's just do this. Let's say that you have a item you're going to look at. Prices are going to go up 12%. Oh, a few times they have. How much would an item that was $480? So when we're looking at this, 12%, of course, it's 12 out of 100. We want to know how much that is out of 480. So 12 times 480 divided by 100 is going to give us what? 57.6? $57.60. That's the increase, though. That's not the answer. The answer is that how much would it be? Well, $480 is the original price, plus the increase of $57.60 gives us, $537.60. That's what it is now after the increase. Now, we could do it that way where we add it on, or we could look at it this way. We had an old price, or a price before. To that, we added an increase, and we got a new price, or a price after the increase. In a percent problem like this, every number, or every item is described by 2 numbers. In this case, there's a dollar amount here, but everything is also described by a percent. the beginning amount or the full amount is usually 100%. So the old price was 100%. The increase was 12%, which means that the new price, well, it's old plus increase equals new, right? 100 plus 12 is 112. The new price is 112%. So what we could have done here, instead of finding 12% and then adding it back together, we could have just found 112%. Cross multiplying and dividing, 112 times 480 divided by 100 is $537.60. So you'd get that answer in a single calculation instead of having to add it back on. Now in a problem like this, it is just as simple to find the 12% and add it on as it is to say, okay, 100 plus 12 is 112% and go from there. And in this next example, it will be too. Let's say an item that was $70 is marked up 30%. Find the new price. So here again, you could find 30% of 70, which is just 21, and add it on to get 91. Or, after the increase, it's going to be 130%. Where does the 130 come from? Yeah, full price, so the old price was 100%. If we're increasing by 30%, 100 plus 30 is 130%. So we're finding 130% of that beginning price of $70. Cross multiply and divide, we get 91. Now, as I said, it would have been just as simple here to find 30% of 70, which is $21, and add that to 70 to get 91. But there are problems where that does not work. Let's say after a 12% increase, an item costs, let's see here, $728. Find the original price. Can I find 12% of 128 and subtract it? Obviously, if I'm asking, the answer is probably no. Why not is the better question. Well, because every percent has a number that it is based off of. 12% in this problem is not based off of the 728. Because is the 728 100%? No. Percent calculations are based off of whatever is represented by the 100%. That's not the 728 here. The 100%, as when we were looking at it before, you have old price plus an increase gives you a new price. The 100% is the old price, not the new price. The 728 is the new price. So we can't find 12% of 728 and subtract it. What we can do, though, is realize, okay, the old price is 100%. The increase is 12%, which makes the new price 100 plus 12, or 112%. So 112 out of 100. Where does the 728 go? Yeah, it goes with the 112, because it's both describing the new price. So we cross multiply. 100 times 728 divided by 112 is $650. The old price is $650. Had we tried to find 12% and subtracted it, what would have happened? Well, we would have got the wrong answer, but how wrong would it have been? Well, 12% times 728, $87.36. If we subtract that, we're going to get what? 245.64. Does that look right? No, that's not right. 241.64, isn't it? 641. Wow. Okay. I'm just gonna, yeah, it's nap time. Sorry. I don't know what I was subtracting it from, but yeah, $640.64. There we go. That is $9.36 off. That's not good. Because the 12% is not based off of the 728. Based off of that original amount of 650. So we cannot put the 728 with the 100% because they're not linked together. They don't represent the same thing.
You're going to throw one of those on the test.
Possibly. Sure, we'll do one or two more. After a...
Are you gonna, if you put it on the test, will it be worded basically the same way? So it will be easy to
identify? I'll try to word it close to it.
Okay.
After a 34% increase, a part costs $268. Find the old price. I'm going to write this down this way. We have an old price of some sort, and it is being increased. An increase is added to the old price. After we add that increase, add that new amount to the old price, we're going to get a new price, a new amount. And as we've said, in every percent problem, each item is described by two numbers. One of those numbers is a percent, and the other number is either a number or a dollar amount. And in this case, it is a dollar amount. So if we fill in some dollar amounts here, $268 goes where? Well, after the increase implies that it is the new price. The fact that we're looking for the old price means it's definitely not the old price, right? On the other side, we have the 34% increase. But there's always one other number that we have, and that is 100%. It's going to be the starting amount, the old price. From there, what can we find really quickly? First of all, can we use this $268 for anything right now? At this point, we can't because we don't know this number. To use that $268, we got to know the number on the other side of it. What is this number going to be over here? 134. 100% plus 34% is 134%. What number are we looking for? The old price right here. Do we know the number on its other side? Yes, we do. 100. So what we have, in fact, what we can do here, by the way, is I can do this. This line we don't really need. I can cross it off. And I can cross multiply and divide right in the table. 100, come on. 100 times 268 divided by 134, $200. Let's have you guys try one all on your own. Yep. A plane ticket costs you $450. You plan to cancel, or you need, I shouldn't say plan. If you plan to, you went and bought it. You need to cancel your flight. you are informed that there has recently been an 8% increase. And your refund would be for the old amount. How much is your refund? In other words, the price was $450 after an 8% increase. What was the price before the increase is what that's asking. So here, just like before, we have an old price. We're going to add an increase to it to get a new price. There's percents describing them, and there's dollar amounts describing them. For percents, the old price, of course, is 100%. How much is the increase? 8%, which comes out to 108% is the new price. On the other side, what dollar amount do we have? $450. Where does it go? It is the new price. What are we trying to find? Old price. This amount right here. So we don't care about this. That line's no good. Why is that line no good? Because we're missing one of the numbers. We need to use the line where we have both numbers, which is the new price, right? The percent and the dollar amount. And then we need to use the line that has what we're looking for, which is the old price. And in order to make that work, we have to have the number on the other side, and we do. So now it is cross multiply. What two numbers are we going to multiply? 100 times 45. Those are the two that are diagonal from each other. So that's 45,000. 100 times 450, I should say. Divided by 108, which should be $416.67.
Another way to check it if you did mess it up?
Is to just multiply that by 1.08 and make sure it goes back to 450?
No.
Okay.
If you screw up and you accidentally times 108 by the 450 divided by the 100,
It comes to be larger?
it comes larger and you know it's wrong.
Yeah. You know it can't be larger because it's got to be smaller because it's been increased to get to that amount. Had you found the 8% and subtracted it, you got $414, which is not correct. $2.67 off. Okay. How about discounts? An item marked $52 is 30% off. Find the discounted price. Well, here again, we could find 30%. 30% is 30 out of 100 of 52. And we would do 30 times 52 is 1,560. Divided by 100 is $15.60. That's 30% off. But of course, that's not our answer. What do we have to do with that? Yeah, 52 minus $15.60 will give us $6.40 is our new price. Now again, just like before, we could look at it this way. We have an old price or a list price or whatever. We're going to subtract a discount. Get us to a new price or a discounted price or whatever you want to call it. The words here don't matter as long as you know what they're standing for. And of course, they're represented by dollars and percents again, like they are in every percent problem. And on the percent side, the old price had to be 100%, starting amount. The 30% is the discount. So what does that make the new price? Somebody's going to say 130, I know. It's 70. Why is it 70? Because you're subtracting. A discount is subtracting. We're not increasing, we're decreasing. 100 minus 30 is 70%. So what we could have done here, instead of finding 30% and subtracting it, we could have just found 70% of 52. And when we cross multiply and divide, this would have come out to be $36.40. What do you think? Good stuff? Exhilarating? Can barely stay in your seats if the excitement is getting to you? You can see I can barely stay in my seats. Let's see here. It is. They took my fan. It usually is freezing in here. Let's say that after a 40% markdown, you pay $25.20. Find the original price. This goes back to just like the ones we were doing before with the increases. We cannot find 40% and add it back on because 40% is not from the 2520. It's from whatever the original price was. So we have an original price. We subtracted a markdown or a discount or whatever you want to call it to get a new price or the amount paid or whatever you want to call that. As I said, the words don't matter. It's what they stand for that matters. And each item is described by percents and again by dollars. We got the 2520. Where's that go? New price. That's what we paid after the discount or the markdown. The 40% goes markdown right here. Other side, on the percent side, because it's a percent, of course. What else do we know? Always one more piece. We always know 100% is what we start with. So then what goes here? 60, good, because it's a markdown, it's a decrease. We subtract the 40 from 100. And we're looking for the original price right here. So again, I'm going to ignore that row, and I'm going to do 100 times 2520 divided by 60 is, what, $42? It's the original price. I'm sensing that you guys want to try one of these. There might be a little sarcasm there, sorry. Let's say that after a 35% discount, you pay $39. Find what the full price was. What's it going to come out to be? What'd you guys come up with? 60 bucks? Let's take a peek. So we have 100% minus 35% is 65%. I'm skipping the words in here. On the other side, $39 goes here. And we're looking for the top one. So 100 times 39 divided by 65 is $60. How many of you had 60? Good deal. Well, then I think you've earned a break It's 4:19. Let's come back at about 4:29.